Hi everyone, J3X here. In this video, we're gonna talk about Liskov substitution principle. So the Liskov substitution principle is part of the solid design principle that was invented a long time ago by some cool nerds. So that is the solid design principle is the single responsibility, open and close, scope substitution, interface segregation, and dependency inversion. Okay, so you don't have to know it if you're just going to copy and paste, and if you're just going to just use a maybe boilerplate, you don't have to do this. But for those who wants to do this, this is the Liskov substitution principle. Right, so we are going to give a bad example on how to use um, inheritance because Liskov substitution is like a principle that is very specific or addresses the how we do inheritance in our object-oriented world, how we do interfaces, or how we do abstraction. So in here, we have an example here. We have a rectangle, and a square. So if you're going to say that a square is a kind of rectangle, then we are going to have a problem because the width and the height of a rectangle uh, differs in its calculation. So a width and height of of a square should always be equal to each other. The width is equals to height for a square, but for the rectangle, it's not always, or um, a rectangle is not a square, so it's not always. It's possible that a rectangle has an equal width and height, so it's a square, but if it's built as a rectangle, then it's a rectangle. So, but here, if you're going to say that a square is a kind of rectangle, then you're going to violate the Liskov substitution principle. So, yeah, this is also partly on the subject of domain-driven design, where you can't model the entire universe using your code. You can only model, you can only create a model according to how you're going to use it. Like, for example, the map of the world. So the map is not a sphere, and it's a rectangle. And then they just make some tweak on it. So, like, I'm not sure what's the name of those mapping models, but that is a perfect example on how we model things on our programming. Um, yeah, so enough of that. Let's just go back to Liskov substitution principle. Okay, in here, this is the example where we say that this is a bad example of inheritance, where you say that a square is a rectangle because if you're going to use a square here instead of a rectangle, you're going to, instead of using this one, you want to swap it. Like, I want to use the square here, all right, and assign it to a rectangle. But since you're expecting a rectangle here, and then you say that rectangle that width is 5 and rectangle that height is 6. So if you're going to expect that the result is 30, no, it's not, because it's going to use the calculation of the square because you're assigning something here, but the calculation is done here on the square. So this is just the output. So the rectangle is going to have 36 in this case. So let's uh, run this. See here, it's 36. It's going to use the last value. So if you're going to put this here, so it's going to be 25. 5 times 5, 25. Yep. It's because it's using the square example. So you cannot use the square in place of a rectangle here. So that's if you cannot you do that, then that violates the Liskov substitution principle. You should be able to use a base class or a subclass in place of a base class. And yep, so a bonus round here is you cannot you cannot assign the rectangle a parent class into a into your subclass, so that is also not possible. I believe this is related to the dependency inversion, if I'm not mistaken. All right, so that's it. Hopefully, yeah, it's 6 minutes. Yeah, that's cool. Right. So cool, 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 cool. Pew, pew, pew.